Sheila?
You got it, yeah.
I have only. And you can leave the hydrogens off, but do put dashes on. How far can you see me wandering over here? Still?
Stop right there.
And how far can I wander over here?
You're good.
Good. All right. Okay, good. Hold up your board. Let's see. Be proud of your work. Let me see what you got. Okay, looking good. Good, 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 good. Everybody's got pentane. All right, excellent. Okay, yeah, you got double duty. Okay, so. All right. What's the molecular formula for pentane? Austin?
C5H12.
Good. C5H12. All right. So there's your molecular formula. Okay, now, don't erase it, just add this to it. Want you to put another one on. Okay, so everybody draw that. Just add it to it. And now what you really ought to do is get out your notes and do the same thing. Because we're going to go a stepwise progression. So start with pentane, and then we're going to add a carbon to it and name it. And you can leave a name for a title of today's topic, which I'll get as soon as we do this. All right, so who wants to guess what we might call this? Well, first of all, let's give the molecular formula. What's the molecular formula for this one, Tyler? C6H15? Hope not. Is it? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I only see 14. You see 14? You see 15? See in double? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The other what? Okay, gotcha. Never mind, I like that. All right, C14. Which looks like what? What do you know is C6H14? Hexane. All right, so is this hexane? No, it's not hexane. It's not hexane because this carbon's in kind of a weird spot, isn't it? It's not attached to the end, but it's a side chain. And so it makes a difference where the carbons go, if they're in a straight line or if they're branched. And we've learned before that every time you change a little bit of something in a molecule of an organic chemical, you get a new one. So we have a new one here. And so that's the subject of today's topic then. We've got a new category of organic compounds. It is still a hydrocarbon. And remember yesterday under there we had alkanes, alkenes, alkynes, cyclic hydrocarbons. Now you can add one more to that, and that is branched hydrocarbons. Branched hydrocarbons. In other words, it's a main chain with a branch on it. This is a pretty short branch. It's just a little stubby branch, but you can have longer branches as well. And we'll get some of those. So, branched hydrocarbons. So this is an example of a branched hydrocarbon. And now we have to learn how to name these, because they're a little bit different than your regular alkanes. It's an alkane with a branch on it. We're going to have 4 or 5 different steps. Here's the good thing about this. You don't have to memorize this name. You simply have to learn how to read it. Just like you don't have to memorize all the books in the world. If you want to know what's in one, you simply read it. Same thing here. You can't possibly memorize the names of millions of organic compounds, but you don't have to. All you have to do is learn how to read them. And so what we're going to learn today is how do I read this and therefore know what it is. Okay, so we're going to have 4 or 5 steps. So here's step number 1. Step number 1, find and name the longest chain of carbons. Find and name the longest, we'll call it straight chain of carbons, even though they don't have to be straight. Find and name the longest straight chain of carbons. That's rule number 1. Brantley.
If there was another carbon underneath the red one,
Yes.
would that be the longest?
Yes, it would. Yep. Good point. All right, now here's what I mean by a longest chain. The longest straight chain doesn't necessarily have to be straight. It can have kinks in it. It can curve. But straight means this, that you can connect all the carbons without lifting your pen or without retracing your steps. So here, that's what I mean by it. So we can start there and go 1, 2, 3, 4, 5. But there's no way we can get that one without retracing our steps. So you may do that. And you can't lift up your pen and go over there. There's another way to do this, and that would be this way. I'm not going to draw it here because I don't want to mess it up, but look here. We could go 1, 2, 3, 4, 5. That would also work. It's going to end up being the same thing no matter which way we name it. Okay, so rule number 1, find and now name the longest straight chain. Well, what is that? What have we drawn a line through of your alkanes? It'll be one of the alkanes. What alkane is that? Pentane. It's pentane, right? 5. So this becomes pentane. Now we're going to write like Chinese from right to left. I'm assuming that's what they do. I don't know. But we're going to add to it this way. So leave some room out here. Can you see me out here, Bree? So pentane, and we're going to write from right to left, so we need some room out here. Okay, so that's rule number 1. Simple enough, right? Okay, rule number 2. Find and name the side chain. All right, sounds pretty simple because I wrote it in red. Find and name the side chain. And so, what should we call this side chain? Looks like a what? What does it look like, Wes? Good, looks like methane, right? Okay, but we're not going to call it that. So now I got to slip something else in here. We're going to take our alkanes and convert them into alkyls. All these names. We're going to take our alkanes and convert them into alkyls. Sounds scary? It's really very simple. An alkane, for example, is CHHH. You convert it into an alkyl by simply taking one H off. CHHH. And there's not an H on there. So in other words, an alkyl is simply an alkane with a hydrogen removed. And you see that's really what we have here, right? The thing in red, it's not really methane because methane's supposed to have 4 hydrogens, and this one only has 3 because it used one of its bonds to join with that carbon. So how do we name an alkyl? Pretty simple. This is methane. This is methyl. Usually we say methyl. But it's an alkyl, so it's methyl. And so you can do that with all of them. So ethane becomes what? Ethane to, everybody say, ethyl, and propane to propyl, and butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl. So you can make side chains out of any one of those. Okay, so our side chains are alkyls. So we just have to change the name a little bit. So instead of calling this methane pentane, what should we call it? Methyl pentane. You guys are kind of dullards today. Methyl pentane, right? Methyl. All right. Now, let me get some of this out of the way here so that we can see things here. All right, so there's our methyl pentane. Now the question is, if I took this methyl group and stuck it here, would that make it a different compound? Yeah, it would. Remember, in organic chemistry, anytime you move a carbon around or something, you've made something new. So not only do we have to say what the alkyl is, but we have to say where it is. So that's rule number 3. Rule number 3, number your main chain in such a way that the side chain is on the lowest numbered carbon. One illustration will make that all very clear. Once again, number your main chain in such a way that your side chain is on the lowest numbered carbon. All right, what does that mean? Well, that means this. We can number our main chain from left to right. Let's do that. So if we number from left to right, this becomes carbon number 1, 2, 3, 4, 5. Or we can number right to left, in which case it's 1, 2, 3, 4, 5. And it makes a difference because if you number it the green way, this methyl group is on number 2, but if you number it the blue way, it's on number 4. And if we want everybody in the world naming these things the same way, then we have to agree. Are we going to number from left to right or right to left? And I guess they could have come up with a rule, you always number left to right, but they didn't. Instead they said, always number in such a way that the side chain is on the lowest numbered carbon. So what are we going to choose, the green way or the blue way? The green way, right? The green way. The green way puts it on number 2. The blue way puts it on number 4. So according to this rule, we have to number this one left to right, and we then add the number to our name, and this becomes 2-methylpentane. And there's our name, 2-methylpentane. All right, I saw some hands. Any questions? Any part of that you don't understand? Austin?
What would happen if you had more than one?
Yeah, and that's going to be rule number, what are we up to, 3? That's going to be rule number 4. But we aren't going to get there today. Zach?
So you only count the one carbon that comes off, you don't count the carbon next to it?
The what?
Like for the chain, you only...
Yeah, you just count the one that comes off. That's a good point. You don't count the one that's part of the main chain, because otherwise you'd have ethyl, wouldn't you? Is that what you're suggesting? Yeah. So you just count, that's why I wrote it in red, so you can see it's just the one that comes off. Yeah.
What if you put the red one above?
Okay, we're gonna, okay, good. If we take this red one and put it above, it doesn't change anything, because these molecules can rotate in space, right? And so if it flipped 180 degrees, it would be on the top. So it doesn't make any difference. All right. Well, we're about out of time there, so I think rather than going on, we'll stop there and we'll pick it up again tomorrow. Don't have class Friday, which is a shame. Oh well.
Turn it
So,
off now.
yeah. So how many